Hello, myself Tadekar sir. Today we are going to discuss our fourth unit, solutions of algebraic and transcendental equations. Already we have seen our three topics. Now we are going to discuss with solutions of algebraic and transcendental equations. First, what is meant by equation? An expression involving equality sign is called an equation. For example, 2x plus 6 is equal to 0 and x plus e raised to x is equal to 0. Both the expression contains equality sign. Means simple meaning of equation is that whatever the mathematical expression given which contains the equality sign is called an equation. Now, an expression of the form f of x is equal to a naught x raised to n plus a1 x raised to n minus 1 plus a2 x raised to n minus 2 plus up to plus an, where n is a positive integer, and a naught, a1, a2 dash 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 an are all constants, is called the polynomial of degree n if a naught not equal to 0. Polynomial of degree n means highest power of x is here n, and which is always positive integer. This is called the polynomial, or this is the definition of polynomial function. Now we are going to discuss what is meant by algebraic equation. The equation of the type a naught x raised to n plus a1 x raised to n minus 1 plus a2 x raised to n minus 2 plus an is equal to 0 is called an algebraic equation or polynomial equation. Means algebraic equation contains the terms of powers of x and constants and equality sign is called the algebraic equation. Now we are going to look transcendental equation. The equation which is not algebraic is called the transcendental equation. Here spelling of the algebraic is ALGEBRAIC should be there, and it's called the transcendental equation. The equation which contains some exponential, logarithmic or trigonometric functions is called the transcendental equations. The difference between algebraic and transcendental equation is that algebraic equation contains only the terms of x and constant, but here in transcendental equation it contains maybe trigonometric, logarithmic or exponential. For example, here given that sine 2x plus e raised to x minus 1 is equal to 0, which is a transcendental equation because it contains sine 2x and e raised to x. E raised to x is exponential and sine 2x a trigonometric function. Similarly, following next example is x plus log x plus tan 3x is equal to 0, in which log x and tan x are present. Due to this is a example, or these are the examples of transcendental equations. Now we are looking some properties of equation, some basic properties of equation. Every equation of nth degree has exactly n root. If our given equation is quadratic, then it has a 2 root. That is if our given equation is cubic, then it has 3 roots. Maybe it may be repeated or non-repeated, it depends on that equation. The value of x which satisfy f of x is equal to 0 is called root of f of x is equal to 0. The value of x which satisfy f of x is equal to 0 is called root of f of x is equal to 0. Means the equation which satisfies the value which satisfy x is equal to 0 is called the equation. Every equation of the odd degree has at least one real root. This is our fundamental theorem of polynomial. Every equation of odd degree has at least one real root. This is very important property for polynomial. These three properties are very important for the objective basis. Now we are going to look our first method, bisection method. Before that, our important theorem is intermediate value theorem. It says that if f of x is continuous in open interval ab and f of a and f of b are of opposite signs, What is mean by opposite signs? Means f of a is positive, then f of b must be negative, or if f of a is negative, then f of b must be positive. This is called the opposite signs. Then there is at least one root lies between a and b. Then there is at least one root lies between a and b. This is very important theorem for the next our this chapter. Now we are going to look at the what is meant by bisection method. It is used to find the roots of the algebraic and transcendental equation. Here mistake is there, spelling mistake, concentrical here written, but actually is transcendental here. It is based on the properties that if f of x is a continuous open interval a b and f of a and f of b are of opposite signs, then there is at least one root lies between a and b. This is the intermediate value theorem our. Now what is meant by working rule, or what is the working rule of bisection method? Select two values, say a and b, by using that intermediate value theorem. Then find f of a and f of b. Suppose that f of a and f of b are of opposite signs, then first approximation is x1 is equal to a plus b by 2. Then find f of x1. Means after the finding the values of a and b, just check the values of f of a and f of b, which are opposite signs. Opposite signs because it should contains our root, or our first approximation towards the root is x1 is equal to a plus b by 2. Then find f of x1. Then there will be two cases. If f of x1 is greater than 0, and here assumed that f of a is positive, therefore if f of x1 is greater than 0 and f of a is also greater than 0, then our root lies between x1 and b, because if f of a is positive, then f of b is negative, because they are of opposite signs. And here f of x1 is positive, and if f of b is negative, then definitely by that intermediate value theorem our root lies between x1 and b, and our second approximation becomes x2 is equal to x1 plus b by 2. If another case is here, if f of x1 is 0, then it is the root, because we know that by definition what is meant by root, which satisfies given equation is called the root. If here f of x1 is 0, then x1 will be the root. If not, then go to the next approximation, x2 is equal to x1 plus b by 2. So our second case is now, if f of x1 is negative, means f of x1 is less than 0, then root lies between a and x1, because our value of f of a here assumed that f of a is positive, and here f of x1 is negative. They are of opposite signs. Therefore by that intermediate value theorem, a and x1 contains our root, means our root is lies between a and x1. Then second approximation, similarly, if f of x1 is 0, then it is our root. If not 0, then go to the next approximation, x2 is equal to a plus x1 by 2. This is the theory of our bisection method, or this is working rule. Now we are going to study some examples. Find positive root of x cube minus x is equal to 1 by bisection method, and here also given that perform 4 approximations. Means for 4 approximations only we have to find 4 approximations. Sometimes they are not given these things, perform 4 iterations, or sometimes they may give like here they are given that perform only 4 iterations. We have given that f of x is equal to x cube minus x is equal to 1. If we shift this right handed 1 to the left hand, then our f of x becomes x cube minus x minus 1. This is our polynomial, cubic polynomial. And first we have to use that intermediate value theorem. For that, put x is equal to 1 here, we get f of 1 is equal to minus 1. And if we replace x is equal to 2 in given polynomial, we get the value f of 2 is equal to 5, which is greater than 0. And here if f of 1 is negative and f of 2 is positive, then by our intermediate value theorem our root must be lies between 1 and 2, and by that working rule 1 and 2 are very important values for us because it contains our root. In between our root is present, therefore f of 1 f of 2 are opposite signs. Root of f of x lies between 1 and 2. By that working rule our first approximation should be 1 plus 2 by 2, means our first value a is 1, here b is 2, a plus b by 2 is our first approximation. Here a is 1, b is 2, therefore x1 is equal to 1 plus 2 by 2 is equal to 1.5. After calculating we get x1 is equal to 1.5. Now our next step is find the value of that f of x1. F of x1 means here x1 is 1.5, and if we replace x is equal to 1.5, we get in that polynomial we get 0.875, and which is greater than 0. Here f of x1 is greater than 0, and therefore root lies between 1 and 1.5, because f of 1 is there negative. We have seen that f of 1 is negative, and here f of 1.5 is positive. Therefore they are opposite signs. F of 1 and f of 1.5 are opposite signs. Due to this our root lies between 1 and 1 plus 1 and 1.5, and these are our a and b, new a and b. Therefore our second approximation is x2 is equal to 1 plus 1.5 by 2 is equal to 1.25. Then f of x2, our next target is find that f of x2 is it positive or negative. F of x2, if we replace x is equal to 1.25 in our given polynomial x cube minus x minus 1, in that after calculating we get minus times 0.2968, and above value we know that f of x1 is here positive and f of x2 is negative. Therefore they are of opposite signs, and by that same theory root lies between that two values 1.25 and 1.5. Therefore our next approximation is similarly, this is our same working rule for each step. Next approximation is x3 is equal to arithmetic mean of that two values, means arithmetic mean of 1.25 and 1.5. x3 is equal to 1.25 plus 1.5 divided by 2 is equal to 1.375. And again our same, find the value of f of 1.375, is it positive or negative. Here if we replace x is equal to 1.375 in our given polynomial, we get the value 0.2246, which is a positive, and previous value is negative. We have seen that previous value is negative, here next value is positive, and due to this our next approximation, fourth approximation, x4 is equal to 1.25 plus 1.375 by 2 is equal to 1.3125. This is our fourth approximation, and we have given in example that only perform the four iterations. This is our four iteration or fourth approximation. Therefore x4 is equal to 1.3125 is our required approximate root of given polynomial. Okay, this is the first example, or if you have some doubt regarding with this method, you can ask anytime. Now we are going to look our next example. Assume that a root of x cube minus 9x plus 1 is equal to 0 lies in the interval 2, 4. Find that root by bisection method. Performs 5 iteration. Sometimes they can give that in which interval root is lies or belongs, and up to which iteration we have to work. Here they have given that perform 5 iterations, and our root is lies between this interval 2 and 4. In that example, how to work or how to solve such a kind of example, we will now going to look this. Here we have given that f of x is equal to x cube minus 9x plus 1 is equal to 0, and f of x is equal to x cube minus 9x plus, this is our polynomial, cubic polynomial, and they have given that interval 2 comma 4. Therefore our first target is find the value of f of 2. Here if we replace x is equal to 2, we get minus 9, which is negative. If we replace x is equal to 4 in our given polynomial, we get f of value of that 4 is 29, which is positive. Means f of 2 is negative and f of 4 is positive. They are of opposite signs. By our working rule, root must be lies between that 2 and 4. Therefore our first approximation is x1 is equal to 2 plus 4 by 2. Means here a is equal to 2 and b is equal to 4, and arithmetic mean of that 2 is our first approximation. X1 is equal to 2 plus 4 by 2 is equal to 3. And our next target is same, find the value of f of x1. If we replace here x1 is 3, and if we replace 3 in our given polynomial, we get 1, which is a positive again. And we know that f of 2 is negative, and here we have obtained that f of 3 is positive. Therefore our root must be lies between 2 and 3, because they are of opposite signs. Therefore by our same working rule, second approximation is x2 is equal to arithmetic mean of that two values 2 and 3, that is x2 is equal to 2 plus 3 by 2 is equal to 2.25. Again same procedure is there, find the value of f of x2, which is positive or negative. Here if we replace x is equal to 2.25 in a given expression, we get negative minus times 5.875, which is negative. And above value f of x1 is positive, here f of x2 is negative. Therefore root must be lies between x1 and x2. Here x1 is 3 and x4 x1 is 3 and here x2 is 2.25. Therefore our root must be lies between 2.5 and 3. Again same procedure is there. Next approximation is arithmetic mean of these two values 2.5 and 3. Therefore x3 is equal to 2.5 plus 3 by 2 is equal to 2.75. Similarly we have to work like this, and after working or stepping we get our fifth approximation is here. X5 is equal to 2.9937. Therefore our approximate root is 2.399375, because they have only given that perform 5 iterations, and here fifth iteration is 2.937, and this is our required root. Now next example, find the positive root of x minus cos x is equal to 0 by bisection method, and perform first 10 iterations by taking radian mode. They have also given that radian mode, use the radian mode. Sometimes they use radian mode or not. If they have not given radian mode, then use our degree mode. If they have given radian mode, then use that radian mode. Here we have to use radian mode, and given equation is transcendental equation here, because cos x is present in our f of x. Our f of x is x minus cos x. Due to the cos x, this is our transcendental equations. First, how to find these two values are important, in which root lies. We have to check some basics values 0, 1, 2, 3. One by one we have to check. Put these values in our given equation, replace that values in our equation, means 0, 1 and 2. Try for this, and amongst them we get our required value. Here if we replace x is equal to 0, we get 0 minus cos 0, but cos 0 is 1, and minus times 1, means if we replace x is equal to 0, we get minus 1, and which is less than 0. And if we replace x is equal to 1, here 1 minus cos 1, if we get after calculation 1 minus cos 1 is 0.4596, which is greater than 0. and here we have observed that f of 0 is negative, f of 1 is positive. They are of opposite signs, therefore by that intermediate value theorem our root lies between 0 and 1. This is our interval 0 comma 1 in which our root belongs, and these are our first values of a and b. And our first approximation by that working rule is x1 is equal to arithmetic mean of 0 and 1. Arithmetic mean means 0 plus 1 by 2, and 1 by 2 means 0.5. And if we replace that 0.5 in our given equation, means we have to first find that value f of 0.5, then 0.5 minus cos 0.5, we get minus times 0.3775. Here we get f of x1 is negative, and we know that f of 1 is positive, and f of 0.5 is negative. That's why they are of opposite signs, and our root must be lies between 0.5 and 1. Similarly, our next approximation should be the arithmetic mean of that two values 0.5 and 1. Therefore our next approximation here is x2 is equal to 0.5 plus 1 by 2 is equal to 0.75. Again we have to find a value of f of x2, means if we have to replace x is equal to 0.75 in our given equation, we get f of x2 is equal to 0.01833, which is positive, and our previous value is negative. F of 0.5 is negative, and here f of 0.75 is positive. Therefore they are of opposite signs, root must be lies between these two, and again by that theorem root lies between 0.5 and 0.75. Therefore again our next third approximation should be the arithmetic mean of these values. Similarly work like this, they have given the target that perform the 10 iterations. Up to 10 iterations we have to work there, and after at the 10th iteration we get, here we observe that x10 is equal to 0.73915. this is our approximate root of given polynomial x minus cos x, which is very important example for exam. And this is, if you have any kind of query or doubt with this lecture, you can discuss with me. Okay, so we will meet in our next lecture. These two given example, fourth and fifth example, for your homework. Find the roots, approximate root of that two, and show me in our group. Okay, thank you for watching this video, and okay, take care.